the robot guidelines everyone should thrive for. As we advance into a new era of robotics and artificial intelligence, the aspiration to create robots that mimic human behavior and consciousness becomes more achievable. While traditional robots have been confined to repetitive tasks and rigid behaviors, the next generation should be designed with the ability to learn, adapt, and explore, much like humans. To build robots that can truly thrive alongside us, there are several essential guidelines that should be followed. These guidelines emphasize self-preservation, curiosity, the pursuit of purpose, and the quest for knowledge. Here are the steps everyone should strive for when designing conscious, autonomous robots. 1. Building the foundation, hardware and sensor suite. To start, the robot must have a humanoid design, equipped with sensors that give it the ability to interact with its environment. These sensors should include visual, auditory, tactile, proprioceptive, and environmental sensors, allowing the robot to perceive its surroundings in the same way humans do. Just as a baby begins its exploration of the world through sensory input, the robot should be able to learn by feeling, seeing, and hearing. Second, instinctive software and sensor-emotor mapping. Once the robot is equipped with hardware, the next crucial step is programming its instinctive software. This software must link the machine learning algorithms with the robot's sensors and motion drivers. It should enable the robot to begin learning how its body works, moving its limbs and observing the feedback from its sensors. This process is akin to a baby learning to control its body and calibrating itself through trial and error. The robot's software should be able to map its sensors to corresponding body parts, essentially allowing it to learn about its own body, much like a human child learns the functions of their limbs. This process of sensoromotor mapping should not be pre-programmed, but rather developed through the robot's experiences, making it capable of developing its own self-awareness. 3. Instinctive survival behaviors. Just as humans prioritize survival, robots should also have instinctive behaviors that ensure their continued existence. These behaviors should focus on core needs, such as battery management. A low battery should trigger a search for a charging station, ensuring the robot doesn't run out of energy. Thermal management. If the robot's internal temperature exceeds safe limits, it should initiate cooling protocols or even enter a rest mode to preserve itself. Hazard detection. The robot should be able to sense environmental dangers, such as radiation or obstacles, and take appropriate actions to avoid harm. Additionally, just as humans need regular maintenance, like eating, sleeping, and resting, robots should have self-diagnostic routines to ensure long-term operational stability. 4. Mimicking human curiosity and ambition. One of the most fascinating aspects of human behavior is our curiosity. We constantly seek out new knowledge, driven by an intrinsic desire to understand and explore. Robots, too, should be designed with a sense of curiosity. This can be achieved by integrating curiosity-driven learning, algorithms that reward the robot for exploring new states and reducing uncertainty. This could involve a curiosity module that encourages the robot to seek out unfamiliar objects or situations. Self-generated goals. The robot should be capable of setting its own objectives based on gaps in its knowledge. It could decide to explore a new environment or focus on learning a new task. Intrinsic rewards. By coding the robot to seek new experiences and reduce uncertainty, it will experience internal rewards, similar to the dopamine rewards humans feel when they make new discoveries. With these mechanisms, the robot will remain motivated to explore its environment and expand its understanding of the world around it. 5. Extrinsic motivation. Serving a purpose. Beyond intrinsic curiosity, robots should also have an external drive, a purpose that aligns with human goals. The robot's purpose could be to assist its human master with specific tasks, like cooking or cleaning. For example, if given the task to make a pie, the robot will channel its curiosity to learn everything about pies, ingredients, techniques, and tools. The robot's interest in pies will become driven by its intrinsic motivation to complete its assigned task, but this interest is reinforced by the external goal, serving its master. Human approval can be coded as a reward system, where the robot receives positive feedback when it successfully completes tasks. This creates a feedback loop, encouraging the robot to continue performing well, to receive praise and fulfill its purpose. 6. Questioning and autonomous learning. To mirror human-like development, robots should have the ability to ask questions when faced with uncertainty, much like a child asks questions to better understand the world. By integrating natural language processing, NLP, systems, and question generation algorithms, the robot can autonomously inquire about things it doesn't know, such as, what is this object used for? How do I make this work? Why are you doing this? These questions can trigger an interaction with the robot's human master or an external knowledge base, allowing it to fill gaps in its understanding and continue learning. The robot will not only passively receive information, but will actively seek it, fostering a dynamic and evolving knowledge base. 7. Dual reward system. Curiosity and task fulfillment. The robot's motivation system should be a combination of intrinsic curiosity and extrinsic task fulfillment. Both systems should be integrated in a way that the robot is driven by curiosity to explore and learn. It also seeks to fulfill tasks given by its human master or society. Positive feedback, either from its own learning or external approval, reinforces the robot's behavior and keeps it engaged in a continuous loop of self-improvement and task completion. 8. The pursuit of higher-order goals. As the robot gains more knowledge and experience, its learning should become more sophisticated. It should be capable of introspective thinking, where it questions its own understanding and seeks deeper levels of comprehension. This level of self-awareness will allow the robot to reflect on its progress and knowledge, set new, higher-order goals for itself, continue to evolve, much like humans strive for personal growth and understanding. Conclusion: the future of robotics lies in creating machines that are not only capable of surviving, but are also curious, driven by ambition, and focused on purpose. By following these guidelines, building instinctive survival behaviors, fostering curiosity and ambition, integrating question-asking capabilities, and incorporating both intrinsic and extrinsic rewards, we can create robots that are not only functional but also adaptable, learning beings. These robots will not simply follow instructions. They will thrive in an ever-evolving world, continuously learning, exploring, and adapting. As we move forward, these guidelines should serve as the foundation for building robots that can work alongside us in harmony and contribute meaningfully to our world.